So today we focus our attention on solving quadratics by factoring. What you'll see in the objective section of your notes today is that we actually learn to solve quadratics through 4 different methods. We're going to learn to solve for x by factoring. We're going to take the square root of both sides. We're going to complete the square, and we're going to use the quadratic formula. But for the sake of this first lesson on solving a quadratic equation, we use factoring because factoring is just what we spent a good amount of time on. So to start the video, you're going to want to go ahead and press pause and go ahead and try these 3 warm-up problems just to check your understanding of factoring. And here's a way you could check your warm-up now that you've resumed watching your video. The answer to your first one there, that's a perfect square trinomial, and you can square root method that problem. The answer there would be 4x minus 3, or times 4x minus 3, or as I said, the big kids write it as the quantity of 4x minus 3 squared. Part B, he had to GCF it first, pull out a 3, you end up with 3 times the quantity of x plus 2 times the quantity of x minus 2. And lastly, on part C, you pull out a GCF there of n, and then it is also a perfect square trinomial, n minus 4 times n minus 4. So those are your answers there. On to our lesson. What you're going to see here is a very important property. I actually call it the zero product property. I have a little abbreviation for it. I call this guy the ZPP, baby. Zero product property. It's an important property that allows us to solve a quadratic with factoring. And it basically works like this. You know, I could play a little game with you right now. You could pretend you were, reading my mind, if you will, and I'll say, from time to time, I'm thinking of a number. You're going to try to think of the number I'm thinking of. I'm thinking of a number, and that number is a number that I can take and multiply it by any other number under the sun, and I always get 0 back out. And I'll say it again. I'm thinking of a number, and that number is a number I can multiply by any other number under the sun, and I will always get 0 back out. Do you think you know the number? Good, it is 0. If you do think you know that number, if you did get 0 in your head when I asked that question, you have this sort of intrinsic understanding of what the zero product property does, and it's pretty straightforward. Basically, it says this: if we're going to multiply 2 things together, A times B, and that product gives us 0, then either A has to be 0, B has to be 0, or both. It's a very true statement. And the example that I chose is this. Let's say I multiplied these 2 things together. There's no multiplication written down there. There's no x or a dot, but when we have no symbol, the multiplication is implied. We have 2 things here. We have 3x plus 2 multiplied by 2x plus 5, and these 2 things multiplied together are giving us a product of 0. Right there. Well, if these 2 things are going to come together to equal 0, then either 3x plus 2 has to be 0, or 2x plus 5 has to be 0. And do you see how we can now use this information to help us solve for x in that equation? And now we just solve by undoing. You subtract 2 from both sides, divide both sides by 3. So one of our x values could be negative 2/3. Furthermore, on the second side here, I can subtract 5 from both sides, divide both sides by 2. Bam. Those are the 2 numbers that would actually make this equation, or that expression on the left side, equal to 0. So it's a nice illustration of our zero product property. We need it ultimately to be able to solve by factoring. So let's get into some examples of that. In each of these examples, I am going to solve each of these quadratic equations by factoring. I'm also going to check my work. I'm going to do that in a couple of different ways today, you'll see. Step 1 in doing this process, and several of the methods we use in this chapter here, we have to get one side equal to 0. So for this problem, I would take 2x squared plus 9x plus 7 equals 3. And I would just subtract 3 from both sides rather than moving the other trinomial on the left side all the way over. And then if I simplify this equation, I have 2x squared plus 9x, and then 7, take away 3, is 4. And ta-da, mission accomplished. One side is equal to 0. Step 2, you can factor. Just like you did on your quiz, just like we've been doing in class. Here I'd probably AC group this, so I'd be thinking of, 2 times 4, factors of 8 that could possibly give me 9. That's just going to be 8 and 1. And then I would use this information to rewrite my trinomial in 4 terms so that I could group it. And I do that just by attaching x to each of these guys. Plus 1x plus 4. And we go ahead and we group. So I'll pull a GCF out of the left side there, and then I'll pull a GCF out of the right. So I'm going to pull a 2x out of here. And here we don't have a GCF, so we typically pull out a 1. And then I do see I have my sets of parentheses repeating here, so I'll GCF again. Pull out the greatest common factor of 4. And then what's left over is 2x plus 1. And now our next step we have to, step 3, use the ZPP. Do you see how you have 2 things multiplied together and they equal 0? That means one of those 2 things, or both, should be 0. So we set all factors in the problem equal to 0. And I should say all factors that have an x in them. We'll talk about that in a little bit. So I'm subtracting 4 from both sides. One of my answers is -4. And then if I subtract 1 from both sides and divide both sides by 2, -1/2 is my other answer. To check, all you're going to go ahead and do is take a moment to plug these back into the original equation and make sure that they work. So I'll go ahead and let you do that. And for the next problem, we basically go through the exact same steps. So step 1, we get one side equal to 0, and that step was already done for us. So in step 2, I am going to go ahead and factor this problem, and I'll pull out a GCF. I see they have a common factor of 3x right now. And we'd have 2x minus 1 left over. And now I can go ahead and move into step 3. Step 3, I have to use the zero product property. I have 2 factors, 2 things multiplied together to equal 0. Any factor that has an x in it, I do need to set equal to 0 to solve for that x. Here, if you divided both sides by 3, 0 divided by 3, that's just 0. Whereas if you add 1 to both sides, divide both sides by 2 over here, you get a 1/2. And you could also plug these back in to check, and they do both work. You have a little bit of independent practice, so I'd like you to go ahead and pause. Again, you're going to set 2x squared minus 3x plus 1 equal to 6, and you're going to solve that by factoring. And then I'm going to show you a really cool way to check your solutions in just a moment. Okay, so perhaps you met with some success. To check this, I just need you to see example 2. Here's example 2. What we're going to go ahead and do, I'm going to show you how to check it on your calculator too. In order to check this equation in your calculator, you'll see that you're going to enter the left side of the equation in as y1 and the right side of the equation in as y2. And you're going to go to Zoom Standard and you're going to press Graph. What's interesting is when we set one side of an equation equal to another, what we're actually trying to find is the places where these graphs intersect, right? Think back to our unit on systems of equations. We're ultimately just trying to find places where these 2 things meet. Y equaling 6, that's a horizontal line, and 2x squared minus 3x plus 1, that being the parabola, what we're actually finding when we solve by factors is just the place where these two things meet each other. So let's go ahead and show you on your calculator how you could do that. And you can record the keystrokes down in the notes underneath example 2. But yeah, so all I did in my calculator was I set y equal to 2x squared minus 3x plus 1, and then y2, I set that equal to 6, the right side of the equal sign there, and I press graph. And now I'm going to make my calculator do some of the legwork to find those points of intersection. And all you're going to do is press second and trace. That's our calculate menu. And you're all very smart. I have a feeling you know which option we need to choose here. We're trying to find the place where the horizontal line intersects the parabola. So we're going to choose option 5 for intersect. And then I typically try to get really close to those points that I'm trying to find. So if I want to find that left point of intersection between the parabola and the horizontal line, I just trace to the left. I arrowed over to the left a little bit. It's asking me first curve question mark. To that I say enter. Second curve, I'm also kind of close to that point of intersection there, so I'll press enter and then enter again. And hopefully you got as one of your x values -1 when you factored and solved. We can get the other one by doing the same. Press second in calc. Option 5, intersect, and this time I need to get close to that right point of intersection. So you see I'm arrowing over to the right a little bit. And I'll press enter, and then enter again. And then yes, I'd like you to guess, calculator. And your other option when you factored hopefully was 2.5. So if you got those right on your independent practice, go ahead and pat yourself on the back. That's good. So that's just a real quick way you can check on your calculator. To wrap up our video lesson today, we have an application problem. So we'll go ahead and we'll read this together. It says, you have made a rectangular quilt that is 5 feet by 4 feet. So I like to kind of mark up my diagram a little bit. This here part of my quilt is 5 feet. And that here part of my quilt is 4 feet. You want to use a remaining 10 square feet of fabric to add a nice border that's the same width all the way around, uniform width to the quilt. And what we're going to do here, it says, we're going to answer this question, what should the width of the quilt's border be? So what you can go ahead and think about is that, you know, if we put two things together, the area of the quilt plus the area of your decorative border, what you ultimately get is, you know, the whole diagram, or the whole thing. So this is the area of quilt and border. This is me setting up a verbal model. You're probably saying, well, you didn't declare your variables, Mrs. Lucas. What's act? So for that, I ask you to kind of look at the diagram a little bit. If you'll see here, we have some X's strategically placed on our little diagram. And all those X's stand for is really the width of the border. We're not exactly sure what that border is going to be. So we let X equal that uniform width of the border. I think what's also interesting to note in this diagram is a little bit about how they came up with 5 plus 2x, or for that matter, 4 plus 2x. That's something that's interesting to think about. Let's talk about maybe the 5 plus 2x. Do you see how originally this little quilt here was, you know, 5 feet in length, but then they have to add on an X over here to get the border. And then, oh yeah, they'd have to like add on that same X right over here, that same border. Well, if we do 5 plus the X over here, plus the X on the other side, you just get 5 plus 2X. Furthermore, if you wanted to kind of relate that to how'd they get this 4 plus 2X right here, excuse me, the width of our quilt is 4, and then you'll see that they added an X on up here, and then, oh yeah, they had to add an X on down here. So what we get is this 4 plus x, or 4 plus 2x for that outside dimension. So if you're wondering where they got those, they just got those because of this phrase right here. We had to add that x on all the way around. So the area of the quilt is actually probably something that's not too hard to find because the quilt was originally 4 by 5. So if you think about that, 4 by 5, that's just 20. The area of the border is actually something that they give us. You want the area of that border to be 10 square feet because that's how much fabric you have. And then we have to think about the area of this whole thing right here. So what I'm going to do is I'm going to bust out my red pen here. I need an expression that models the entire area. Oops, went too short. The entire area of the whole thing right now. I know this diagram's getting a little messy. I marked it up quite a bit. That whole thing, the area of the quilt and the border put together, well, that's where these expressions come in super handy. I have an expression for the new length of the quilt and the new width of the quilt. And you folks know that the area of a rectangle is just length times width. So I'm going to do the new length times the new width. The new length in this case is 5 plus 2x. And the new width in this case is 4 plus 2x. So I just had to multiply those two things together to get the area of the whole thing. And then 20 and 10 on that left side there does simplify to be 30. And the technique we're practicing with today is solving by factoring. So I'm going to go ahead and FOIL this right side. 5 times 4 is 20. Be my firsts. My outers would be 10x. My inners would be 8x. My last would be 4x squared. And then I recall from earlier in the lesson that I really can't solve a quadratic unless it is written in standard form. So I would take time to get that one side into standard form there and simplify a little bit. So this would be 4x squared, 10x and 8x is 18x plus 20. And then we really can't solve unless one side is equal to 0. So I would subtract 30 from both sides. And at this point in time, I'm going to have you press pause because I want you to try to solve this now by factoring. And then when you're done, go ahead and hit play again because then you'll get to see how the answer worked out. Okay, so we started factoring. Hopefully you took out a GCF of 2, and then I AC grouped it to get 2 times 2x minus 1 times x plus 5. Notice that I brought down the 2x minus 1 and the x plus 5. But I can't set 2 equal to 0. It doesn't even make sense. Violates the one-to-oneness of our number line. So I wouldn't even set that constant out in front equal to 0 in my DPP. And then what I notice is I get 2 answers for x. I get a half, and I get negative 5. And, well, wouldn't be much of a quilt if we had a border with a negative width. So that cannot be a correct answer. And you might have noticed that this is in feet. So x was a measurement in feet. Or you could say the width of that quilt could be 6 inches all the way around. You write that as a sentence. The width of the quilt would be 6 inches. So that's a nice little bit of practice there. To wrap up our lesson today, you just have a couple of independent practice problems, and then we're going to go ahead and talk about these when you get back to class tomorrow. So that's that.